Thanks for coming to Understanding Cross-Site Scripting. My name's Christina Mitchell, and I'm an application security engineer at Indeed. So I mostly work with third-party and internal application vulnerability assessments. So I get paid to break things for a living, and it's the best thing ever. So I'm happy to come in here and talk to you today about cross-site scripting. Some other things that I do too are triage our bug bounties. So we see a lot of interesting attacks that come in, and our educational efforts. So, this talks, I'm checking some assumptions. It's for fresh beginners and learners who want some more context into application security. There's also some secure development nuggets in here too, so I like to say this is also for engineers and devs, along with our security cohort. So today we will cover what exactly is cross-site scripting, and before that we should talk about browsers and apps to understand what's happening. And we'll also cover how to spot it in the wild, how to remediate it, and how to exploit cross-site scripting. And there's also a handful of different types too. It's stored, reflected, self, blind, and DOM. We'll also discuss some common errors in development to look for, and which browser headers can help and which don't really help you at all. Because sometimes people want to refer to adding some headers. And we even have enough time for a live demo, so fingers crossed it doesn't get too bananas. Okay, so how do browsers work? So at a high level, the client requests and renders resources, so our browser, HTML, PDFs, and JavaScript. There's no formal spec for browsers, and they're still evolving, which is super duper interesting. So there's no difference the difference between the browsers is in how they parse the data and the languages that they're coded in. And this is why you'll find some interesting bugs in different browsers, like Explorer. So now we'll go over a couple different basic browsing building blocks for your web browser. So you type in your URI in the browser's UI or click a link, and it communicates to the browser engine. The rendering engine gets chunks of the requested doc from the networking layer and constructs the DOM tree for HTML and CSS, and it does this gradually. The networking component handles all the internet communication and security, and I bet you can probably guess what the JavaScript interpreter does for us. The UI backend is used for drawing basic widgets like windows and combo boxes, and data storage is our bookmarks, preferences, and cookies. This is so important it deserves its own slide. So HTML has error tolerance. So you find and fix missing close tags and common errors. So for example, if you have a table row outside of a table, it'll rearrange elements on the page. And it might sound kind of innocuous, but it's actually helpful for us later when we come to talk about cross-site scripting. So what is the DOM? I kind of mentioned that briefly. It's important to quantify which spaces cross-site scripting will get its grubby hands on. So document is our HTML space, and window is our JavaScript execution space. So documents, they can access other windows and frames and their docs and send requests on the network and load other sources and get into cookies and the like. Whereas windows represent the browser windows, so the global JavaScript variables live in this space. And we're skipping over a couple things, but this is the important stuff for us. Okay. How do web applications work? Seemingly like magic, but just to make sure we're on the same page, we'll talk about how web applications work. And I wish I had a good pun for page since it's a JavaScript page. Someone help me after if you have one. So this will be slightly abstracted, and if you're curious to know more, afterwards I'll be posting the slides on Twitter with some wonderful resources. But in this example, Yuri wants to visit Indeed.com. Her browser acts as the client to send the request. The request travels through the internet and arrives at our server. Bam! So the server responds with the page data and returning it back over the internet where the browser receives and renders it. Okay. So another thing about applications here, they communicate with the HTTP protocol, and it uses verbs to identify different actions. So there's a handful of them, but we'll mostly focus on get and post. So this is a retrieval of a resource or a get. So when I do the live demo, we're going to be using a tool that looks at these requests. It is getting resources from Indeed. I don't know if you guys can see that back there. Probably not. Okay, so I'll just describe it to you. So the request header this is just information that the browser will see in the header. And it has the verb get, and then it has the resource of Indeed.com, and there's a couple other things in there like user agent. So what am I making the request through? Is it a mobile device? Is it a browser? So it might give me different information back, and it tells me what, accept language and other kind of nuggets here. Because sometimes you can put a header on when you respond to try to negate some cross-site scripting. But we'll talk about why that doesn't work. Okay, so then we get a response from the server, and it looks like this. It'll be a response code telling you if it's successful or not, or if you have to find the resource elsewhere. And there's a couple different options here. But the main takeaway we want to get, because I know you guys can't see it back there, is you have a request header and a response header. And the headers are essentially what the browser is communicating, or being communicated back to the browser, and it's not to the page to render. Whereas the response body here, on the bottom, you'll see some HTML. The response body is the HTML for the client to render. And one interesting thing about our HTTP verbs is that they're conventions. So sometimes when you start speaking about secure design, you'll see that they're abused, and you can find some vulnerabilities in the way the page is built with the inappropriate verbs. Oops, let me zoom my timer here. Okay. Next. All right, so this is just a demonstration of what it looks like. So when you change your user agent, but I'll kind of gloss over this since I know it's going to be hard to see. Essentially, all we do is change the user agent from a browser to a mobile browser, and it sends back different data. Okay, so we want to get to the fun stuff. So back to HTTP verbs. When I was talking about things that you can abuse, GET request should be non-state changing. So retrieve this resource for me, whereas POST is state changing. So send along this data with my request. So I've seen POST URL params that gets kind of confusing. So keep your POST information in the POST body. And later in the talk, I'll be using a web proxy to demonstrate. So a web proxy sits between your browser and the internet so that you can stop and modify information as it comes through. If you guys are familiar with Burp Suite. Yeah. Okay. So, next slides are background and might help illuminate some common misconceptions on how to fix this. So, understanding same origin policy and cross-origin resource policy will help you better understand the client-side vulnerabilities when we get to the meat of the talk that I know you guys are dying to hear. So, if you have two sites open, essentially, how do you keep one site from tampering with the other site? How do you enforce it? So the web was originally just static files, and with the introduction of JavaScript, we needed to add some client-side protection since the server side was what we had prior. So single origin policy gives the browser a system for isolating different resources. So just to imagine a world before single origin policy, so if I, the attacker, can get you to log in to your bank via an iframe to equal.com, then I can change anything in the DOM. So when we talked about what the DOM had access to, I can change your balance. Make it look like it's not changing when I take out your balance and leave a fake balance for you. Take it home with me. All right. So if example.com can load resources from pictures.com and it's not reading content, it's fine. So it's not going to be in violation of our single origin policy. Or using a third-party script include, like an image tag, which will come in handy a little bit later. So remember, JavaScript can alter HTML via the DOM with breakout characters, or different characters allow you to change the context. So single origin policy is an attempt at isolation, to not allow sites to tamper with each other's data. And the origins should match, so scheme, host, and port, otherwise no read or write access. However, you can still post to allow sharing, but not reading the data. So here's just a diagram. Again, you probably can't read it back there. So on the top, I have an origin, which is store.company.com. It's on HTTP. It has a resource, which is our company.com domain here. These are passing requests since they're all on HTTP and they're all the same domain subdomain. And then these will fail. So you've got your protocol in red, that's HTTPS. They're not going to be able to share resources. And then domain in green here on the bottom, it says news.company, can't share with store. And the port, for some reason, they decided to make that 81. So that also will not be accessible to same origin policy. So that's fine and dandy, but what actually does origin get you? So access to origin gets you read and write to cookies, ability to use the browser network, write elements to the page, add event handlers, JavaScript variables. Sounds more interesting. Okay, so what happens if you actually want to share information between these different domains? You relax it on purpose. So there's specific headers called CORS headers. On the bottom here, it says access control allow origin with star, which some of you might guess means any domain can get access to that response page. So when I was showing you request and response, let's say you're making a request to get a new API key, and it dumps it out on the page. So any page would be, any other domain can read that. So don't ever set if you're developing something, don't do that. You want to explicitly list, I want example.com to read my response, elsewise, why bother? Okay. Right. Now we got to the good stuff. I see some smiles. You guys look pretty excited. Yeah. Cross-site scripting. Yeah. So, cross-site scripting is the ability to inject JavaScript into the client side. So let's say you visit your favorite social media site. An attacker was there previously, left a malicious script that's running on the page, and since you know about what it means to have access to the domain, you know that they can rearrange things on the page. They can make it look different. You might not even see it happen in front of you. So the browser can't tell that this isn't intended code from the social media site, and you're not going to see it happen in front of you. Or if you remember, I remember going to websites and getting like 15 pop-ups for like Ray-Bans and things like that. That's probably cross-site scripting here, folks. So to quantify this a little bit better, there's a common e-commerce site recently where individuals can sell and resell goods. An attacker injected a script into the site and stole victims' login credentials. And also British Airways had something similar because a hacker harvested user data in the same fashion. Or an interesting spin, and I know I shouldn't be like rooting for it, but it's pretty awesome and it's clever, to inject a crypto miner. Yeah, that's I see getting excited. So we can do any action that the origin can do. So when we talked about the origin, so it takes advantage of the embed rule of single origin policy that we talked about, and it can do anything. Mostly, but we'll get into the weeds on mostly. All right. Next. So, cross-site scripting is caused by a lack of escaping, which can allow an attacker to change the context. And what I mean by that is encourage the HTML parser to create attacker-supplied HTML element, which has an attribute to call JavaScript. And that's a mouthful. So, let's see. This, actually, I think it's pretty helpful to identify, because usually in these examples you just see script alert. It's any context. It can be CSS, tag names, attribute names, headers, all kinds of places. Anything that you put in the request, I can get access to. So that with a web proxy. So escape everything. To be more specific, again, this is an injection vuln, and the attacker uses breakout characters to add their own payload. And escaping is for every context. So, let's see. Using a HTML tag attribute, escape it. A URL parameter, do that as well. And on the left is an example of some of our breakout characters. Can you see it back there? Yeah, okay, cool. I won't have to do that for you. So, those are escape characters. On the left is URL and, not escape, breakout characters. And the right is HTML. Great. So there's a lot of different types of cross-site scripting. Stored is aka persistent. It's persistently stored on the server side. So whenever you request that resource, it's fed back to you. So scope is whomever visits the page. So the example is attacker posts a malicious comment on a message board. Now you have reflected, so it says non-persistent. It's injected in a URL parameter in the request. Excuse me. So let's say that the application uses a parameter directly into the page during display, and it's included in the response body. It's a little bit more, the scope is more narrow, so it's deployed with a specially crafted link. Let's say you click on something through Twitter, It's there. It's going to execute on the page. And on the example, you've got your user param set to this payload here. So self-XSS. I just want to plug a talk tomorrow. I was talking to someone who's doing the cookie jar talk. This will dovetail directly into it. So I would say go see that talk if you can. So self-XSS, often enough people don't see the value in making sure it's not accessible to attackers because it's paired with social engineering and the scope is a lot smaller. So if you remember a couple years ago, there was a Hack Your Friends Facebook self-XSS where it told you to open up the console and start messing around with things. That was self-XSS. Then there's also blind XSS, which is an injected resource that comes in from outside data. So for example, let's say an attacker modified their username to a payload, and that this information triggered on a internal metric system that takes profile data, where it deploys and calls back to the attacker. That's blind, a little bit harder to figure out sometimes. Okay, and we've got DOM XSS. So this is created at runtime by on-page JavaScript. It's a little bit harder to locate as an attacker personally. I will use something like Burp Suite or a scanner to find it. You can find it with static analysis tools. But at the end of the day, it's still about escaping user input before adding it to the page. And these will be things set to like document.url, location.hash, and document.refer. So these things that we're seeing in the header, you still want to take part in escaping it before you add it to the page. Okay. How do you spot it as an attacker? Whoa, that went fast. How do you spot this as an attacker besides me just talking to you to tell you that you can see it? All right. Man, I'm going way so fast. So you play with the injection points. So for example, sign up for a service, use control characters that we saw earlier and set it to something you can immediately see like an alert. And that's why you often see alerts because it's quick and it's on the page for you. So with blind XSS, I would use a tool called XSS Hunter, and I'll have a link to it in the end of the talk so you can play around with this with caution. So then you wait for the backend service to trigger it, and it might call back to you days or months later. So that's a really high value way to look for this. And with stored, you look for locations where your payload will be stored persistently. So perhaps message boards or anything that's keeping the data server side. So reflected or DOM, depending on how the page is built, you look at requests. Is there a URI parameter being reflected back onto the page? This could require a web proxy to intercept and modify. And with self, can you abuse something like a cookie value, which is, again, Jim's talk tomorrow is really going to be great. Can you inject some values manually? That's the only differentiation between this and some of these other ones. All right, DOM XSS, again, it's an advanced technique, so look with your automated tools to find it, like Burp Suite has some functionality in its pro version. Great, now how do you exploit it? Good stuff. So an easy proof of concept is the alert to the page. You can search the console to see where it's triggered. As far as what you can do with it, it's up to your imagination. You have the front door. So everything we talked about with what you get access to, you can tinker with. It gives you a lot. Side note, accept cookies with the flag of HTTP only set. You're not going to be able to get into that. That's okay. You're going to have everything else. So there are some great cheat sheets to look with access to. Seclists, XSS payloads, XSS payloads, and cheat sheet series. These are all going to be in our resources, so you can see examples of different ones that I've triggered, because you're going to want them to fit your context. So we're talking about the different ways that they can be exploited. I like to look at other people's work too. So now that you know what cross-site scripting is and how to spot it and how to exploit it, how about preventing it? So preventing it is going to be avoiding breakout characters from changing the context and telling the parser to, hey, now I want this element added to the page. Because like we talked about earlier, it's a gradual process. It doesn't happen all at once. So use the tools that you have. Don't roll your own URL parsers or serialization code. Use the built-in XSS prevention. I can't tell you how many times I've looked at an application and seen these safe protections, like in React, the dangerously set inner HTML turned on. It's in the name. It's in the name, right? Or Django has something marked is safe. It's like, this is not safe. Don't do that. There are other ways to do what you want. Let's see. So don't do that. All right. So don't use raw HTML methods, or don't disable encoding with your environment. Let's see. Here's a couple examples. Native JavaScript, you've got inner HTML, eval, or just directly using the JavaScript protocol on the right. Angular has a couple other, like bypass security. Soy has one called no auto escape. I'm sure there are a ton of other ones, but these are the ones I knew off the top of my head. Other prevention. Use an accept list. So let's say, for example, my example of escaping everything is fine, but what if your tool you're making is an HTML generator? Let's say you have to make something so a client can add their own HTML to your site, which sounds really dirty. So you can use something like an accept list of acceptable characters. And we specify accept list versus deny list because deny list, there are a lot of ways to get around something, and attackers have a lot more time than us to develop something safely. So perhaps they use a nested payload. So the first time you look at it, it doesn't trigger because it's SCR and script on this side. And when it gets rid of the beginning of the script payload, it has an actual payload. So the filter might not be recursive. Perhaps you have spaces in the payload and the browser is helping you. And much, much more that we don't even want to think about because we can do it the right way and use an accept list. Okay, so there's different types of escaping. Escaping for elements looks like this. So when I was talking about escaping, that's fine and dandy, but actually seeing what it looks like. So your characters on the left, those were our HTML characters to build our elements. HTML escape looks like this. So if you're tinkering with the page and you're putting your payload in and you go to inspect the element and look at it, if you see this, you're busted. You're not going to be able to play with XSS here. And also XML is very close. You can see that just slash is the only one that's different. All right. Okay, so more about URL encoding. This example from the page renders a user supplied directly from the URL. So on the top, we have a user set to our payload. On the bottom, we see this is escaped, and it's gibberish, and it's not really going to be rendered in the page. So it's not going to fire. Excuse me. Okay. So I talked about headers, and sometimes you can use some headers to help you out with our cross-site scripting. So we have CSP. So Content Security Policy. It's a restriction intended for XSS mitigation. It uses that accept list approach we discussed earlier as being a list of values that are positive to use. Its intention is to narrow down which domains can run code on your site. So above is an example of a header allowing payment.site.com to run. And there's some lax controls here. So just like we talked about earlier with the don't use the star to let anyone run. This is great. But mind you, since we talked about how this works, know that CSP is not a full preventative method. This is going to help you with resources loading and running on the page. It's not a full XSS mitigation. This is just helpful. Also, as an aside, if you do decide to use this, it'll disable inline JavaScript, and some older browsers don't have this protection. So it's just a Band-Aid. And for some of those older browsers that don't have CSP, we have this header called XSS. Say that 3 times fast. X-XSS. You can decide how much or how little protection you want. It can block the web page from being loaded entirely or just not do anything at all. Also, Chrome has a similar auditor. So Chrome will be looking for reflected cross-site scripting. And since we talked about how many different types there are, you can't rely on stuff like this. This is just helpful. And also, as an aside, if you're doing security testing, I recommend using Firefox so you don't have false negatives, so you don't miss out on some of those payloads being triggered. Just fun facts. All right. I'm going to show you a live demo, so fingers crossed it doesn't blow up on me, okay? Yeah, get excited. All right, so first we're going to have reflected cross-site scripting. And I have an instance here of escape. Oh no. Hey, that's our presentation. Okay, so. Okay, you can see it? All right. Here we have Google Greer. And I'm going to show you what reflected looks like. So let's say I just clicked on a link for free sunglasses, and I love them, I want them. Okay, I see people straining. It's hard to see. Basically what this is set to is URL / and then payload. So it's a script alert at the end. And this is being added back to the page. So in the code, I would normally be looking for a parameter like user set to something. But in this code base, if you have an error, it directly adds it to the page or reflects it back to the page. So if I was using Chrome, this would probably be blocked. Or if I had some of those headers we showed about earlier, it would be blocked as well. So you can see here, invalid request to this endpoint. So that's our reflected here. Now this tool, Greer, it's also freely available on the internet if you want to tinker and find some of the other lovely things in here. This tool has some snippets that are stored to the page. So this seems like a very wonderful, opportune time to look for stored cross-site scripting. So let's see. New snippet. We're just going to go for the gold here. All right. Script alert 1. Check it out. Oh my gosh, it didn't add it to the page. Let's take a look. What happened? They sanitize it somehow? So I'm going to inspect it. Dun, dun, dun. All right. Blocked. Whatever that means. Something's blocked. Edit. Okay, let's try something else. New snippet. Okay, so let's try a table row and see if we can get our parser to add this to the page and fix my payload because it's broken. See, it's missing a bracket, and I'm telling it table, and then missing the ends. Let's see what we got here. Oh, hey, also, limited HTML is supported, so I know they're accepting some. I just don't know what it is because I don't have access to their code. Okay, this is getting more interesting. I see this has been moved around on the page, but my payload doesn't exist here where I dropped it. So that's not quite happening, but I can see things being moved around. So let's try this one. All right. Images are great. Let's try an image. Wait, my snippets, new snippet. I can computer. All right, so what this is telling us, what we're doing here is we're going to set this to an image, this is image HTML tag, and it's telling us the place where you can upload this image, the source is set to X, and X is not here, so it's not going to work. But on error, call out to that JavaScript interpreter and do what I say. Let's see if we get it here. Hacked! We did it! All right. I didn't have an example for self, but I think you guys might understand it's if you modify something that's only for your page. So it might be a cookie value. It might be something that you see. And also blind is a lot more challenging to do. So those were our main examples. Let's show you some resources and have some time for questions too. All right. I've got a ton of resources. This will also be on Twitter. I'm going to send this up because it's magnificent. So many resources. So I didn't come up through a STEM degree, so a lot of this stuff I've learned from our community. Portswigger, which is Burp Suite, that's a tool I was using for Proxy, has a great resource on cross-site scripting. Gruyere was a Google intentionally vulnerable application. Google has a game, an XSS game, that's actually pretty challenging. So you sit down and try to work through the next level, exploiting some of the things we talked about. There's some sec lists. So one of the examples I said, go here and see it for different payloads. This is Daniel Messler's sec list. There's also some videos, because not all of us like to read, tons of dense text. Some miscellaneous stuff, some good things about web app testing, some cheat sheets to look at how to test different things, reference material on top 10 vulns, Bug Crowd. This is a great resource. So if you like hands-on stuff like I do, this is more geared towards researchers and testers. So it'll show you different ways to work with testing applications in video format. Books, Web Application Hackers Handbook is de facto good stuff. The Tangled Web, personally, I really like learning about what's happening and why. So the Tangled Web, also one I have not put up yet is there's a book on the HTTP protocol. It's like 500 pages, but it's really good stuff. Okay, intentionally vulnerable web apps. So you want to test your chops and not get arrested, right? Bad Store, Google Gruyere, Metasploitable 3. But if you want to get paid, go work on some bug bounties. You'll get paid to do that. But work within their restrictions. It'll tell you on a bounty page what you can and cannot test. I strongly recommend using these rather than a private bounty. So say if a website has their own bounty and they say contact us, I don't want any hassle. You hear about hackers being sued and things like that all the time. Don't mess with it. Use some of these resources. All right, who's got questions? Don't be shy. I'm also going to post this later. Yes?
You said you triage web bounties security stuff.
Yeah.
How often do you see blind XSS coming in triaging? If and when you do, are they using polyglot payloads or are they
Ooh. Well, I think I might get in trouble if I talk about specifics, because I work specifically for Indeed, so I might get in trouble. But I'll say it's not as rare as I would like it to be. And what I did was, I worked with the team that created that back-end service that it was calling back and put in a CSP header. So even if something did trigger, it wouldn't exfiltrate out. Which it's like playing whack-a-mole, right? If you give people a tool to query things, not everyone's a developer. I mean, even as a developer, I didn't know what I was doing. So, it is worthwhile trying it out because, I mean, there's nothing quite as magnificent. I tested this one product and they swore up and down that they had a recent pen test and they really didn't want to allow me to test. I dropped in some of those blind payloads and getting that callback was just proof positive. So it's worth trying it out. Don't be shy, y'all. Came all the way from Texas. Yes. I actually have to send this to my personal account first because this was work materials and I can't share the Google Drive from my work. Yeah, so I'm going to share it on my personal account later. And that's my handle too. So if you're shy and you don't want to talk in front of a group, we can talk afterwards. Also on Twitter, I like to help other people in the community because I came up through people in my community. So yeah, thank you everybody. Thanks.